The eagle has landed. Right. This is a Zemangeya for you. And this part is on geometrical transformations. Questions that has been worked out from past exam papers. There are different past exam papers that I work out in this video. Then after watching this video, please like, share, and subscribe to this nice, powerful item. Question number 1. This is the question. Right. We have this graph and these triangles, and they're saying, describe fully the single transformation that maps triangle A onto triangle B. Triangle A onto triangle B. A onto B. Right. If you can check, we said for you to be able to identify the different types of transformations, you check first on size. Is size the same? If size is the same, like in this case, you move on to check on direction. Is direction the same? If direction is still the same, while size is the same, that's called a translation. But in this case, you can check size BA, same size, but direction B is now facing opposite another direction. So that one, then you check, are they exactly facing each other? Right? You can say no, they are not exactly facing each other. So it means this one can't be a reflection. Right? Translation has been eliminated. Why? Because direction is changed. So it will either be rotation or reflection. Reflection ruled out. Why? Because the shapes are not facing each other. Now this will be automatically a rotation. It's rotation. So right here, rotation. Then on rotation, you have to write the direction, angle, and center of rotation. Check. You can check one point, this point, and this point. This point here, it was on the north. So this one, the north of the diagram. Now this point is west. So between north and west, it has changed from north to west. So it's 90 degrees, and this one is anti-clockwise. So it's rotation, 90 degrees anti-clockwise. That's the first part. Then you have to find the center of rotation. Center of rotation. So rotation, angle, direction. Angle is 90, direction, anti-clockwise. Then center now. You have to find the center. Center usually, you can use the ruler method to find the center. How? Or you can just use this method. Let me show you. Or using those rulers. Basically, you join n 2 points like this point and this point. These are the corresponding points. So you join them such that there must be 2 rulers that will be making 90 degrees. And on rotation, please take note, distance of the image from the center of rotation is exactly the same as distance of the original point from the same center of rotation. So you check here, a point that will give you like 90 degrees, like you can find the ruler like this and the ruler like this one. The distance, which is this distance from this point to this point, must be exactly the same as the distance from this point to this point. At the same time, these lines must be making 90 degrees. So that will be the center of rotation that we have found, right? So let's check. If I can find my ruler, let me say approximately. If it's clockwise or anti-clockwise, because the line can be like this or can be like this, 90 degrees. From this line, it's always from the original to the image. If this one original, this one is image, then to this angle. So it's anti-clockwise. If this one was the original and this one was the image, it will be like, if we can do it like this, it will be clockwise. But like this, it will be anti-clockwise. So it means these lines, they are correct. That will represent anti-clockwise direction. Right now, let me measure using my ruler the distance now. This one from this point approximately is this center, this point here. Let me check. I will measure with my ruler from this point to the point on the original is 3 centimeters, around roughly 3 centimeters according to my measurement. Then this one is also 3 centimeters. So that's it. And the angle, it looks like it's approximately 90 degrees, right? So this will be my center. So you can try it. Right. Basically, if I used to these things, you can just be able to identify, say, no, the center of rotation is here. it will be easier, actually. Right, so this will be the sender. So the sender is x minus 3, y 2. I can say minus 3, 2. Yeah, you can prove it to confirm whether it's correct. Yeah, but this one looks like it's perfect. Right, then next part, triangle A onto triangle C. Triangle A onto triangle C, size changed. So this one will be enlargement, right? It's enlargement A onto C. So you write enlargement here. Then enlargement, we want the sender of enlargement. Enlargement sender. What is the sender of enlargement? Then what will be the scale factor? Okay. So it's enlargement, sender, and scale factor. Sender you find by joining any two corresponding points. Like I can join this point and this point. Let's join them. These are the corresponding points. Right? Then this point and this point. Let's join them. Approximately. So that's what you do. Wow. So my points, they are meeting at the point, it's x minus 2, y minus 1. So sender, you write minus 2 minus 1, like this. Then scale factor. If the shapes are already drawn for you, then you can just use image side over original side. Image side, image is what? A onto C. So C is the image and A is the original. So image side, I can choose which side. I can choose this side. How many boxes? 2. So it's 1, 2 boxes. And this side, how many boxes? Over 1, 2, 3, 4. Over 4. So it will be half. Scale factor, half. Done. Then next part, draw the image of triangle A after a translation by vector minus 5, minus 10. You can use the counting method, or you can just add this vector to all the points on triangle A. Right? Let's use the counting method, but please take note of the scale. Scale is very, very important. So if you are to count, it means minus 5 in the x direction and minus 10 in the y direction. X decrease is going to the left and y decrease is going downwards. So you count minus 5x and minus 10y. Right, so it's this triangle A, each corner, each point actually is minus 5 and 10. And the scale, it means one box represent 1 unit, right? 2 boxes, 2 units, 1 box, 1 unit. So I can start with this one. Right, that's where x is decreasing. 1, 2, 3, 4, 5. Like this. Then, so it will be 5. Then minus 10 going downwards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's this one. Then the next one, it will be this point. This point 5, 1, 2, 3, 4, 5, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Image will be here. Now this point, the one that is left now, this point, it will be 1, 2, 3, 4, 5, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's here. So let me rub off all these funny items. Okay, so to join now, you join this and this. That's the translation. And so that's the image done. Just like that. If you have a ruler, then you actually have to draw a better one. Then draw the image of triangle A after a reflection in the line y is equals to 4. Line y is equals to 4. So you draw the line y is equals to, is it 4 or minus 4? It's 4. The image A in the line y is equals to 4. So y is equals to 4. You come where y is equals to 4. Then you draw your line like this. Then after that, you reflect triangle A on this line. Distance of the image from the line of reflection, which is y is equals to 4, is the same as distance of the original point from the same line of reflection. So it will be, you count 1, 1. That's where the image is. Then 1, 1. That's where the image of this point is. Then this point to the line. So you count from the point to the line. Then from the line to the image, same number of boxes. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you count also 9 going downwards. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it means the image of that point is here. Right, I have marked my points now. Oh, my line, I need it. Oh. So I need this line y is equals to minus 4. Let me draw it again. Y is equals to 4. That's the line. Then let me join my triangle is this one. Done. That will be the reflection of triangle A on the line y is equals to 4. Done. So this question paper, done. Next question paper, right, this one. The first part, draw the image of triangle T after a reflection in the line y is equals to minus 1. Triangle T, it's here. Line y is equals to minus 1. So you draw the line y is equals to minus 1. You come here where the y is equals to minus 1. Then you draw the line. You label the line y is equals to minus 1. Then you reflect now. The same thing, reflection, distance of the image is the same distance of original point from the line of reflection. So you count this one, 1, 2 boxes. Then 2 boxes here from the line. Then this one, 1, 2 boxes. 1, 2 boxes. Then this point is 1, 1, 2, 3 to the line. Then you count also 3 from the line. 1, 2, 3. This is the shape. Done. That's the reflection on the line y is equals to minus 1. Then next, draw the image of triangle T after a rotation 90 degrees clockwise about 0, 0. 0, 0 is this point. So you mark the center of rotation. That's 0, 0. Mark the center of rotation. 0, 0. This line, you're not supposed to delete it actually. Maintain the line. You have to show it must be there. You don't have to delete it. Right. So it's 0, 0. You have marked. Then you want to rotate 90 degrees clockwise. So it can be like this or like this. Your 90 degrees, right? So from this point to this point, it will be clockwise. Then anti-clockwise. You are coming from this point, right? So it can be like this, 90 degrees, or like this on this side. If it's like this, you check this side, it will be from this point line to this line. Line on the original to the line on the image. It will be anti-clockwise. Then from this to this, it will be clockwise. So it means it's supposed to be this line. So you delete this one. It's supposed to be approximately like this. But you have to link with the center of rotation. Now, let me delete. So you link with the center of rotation. So center, so it can be like, so with the center, you link like this. It's either this point can go up or can go down like this. So you check which direction, the black or the red line, that will give you a clockwise direction because they say it clockwise here. So you check this side from the original, this side will be clockwise, this side will be anti-clockwise. So it means we consider the red line. We rub off the black one. Right. Right, so it means the red line. Now on the red line, the angle must be approximately or exactly 90 degrees. So you check on the center. And distance of the image from the center of rotation is exactly the same as distance of the original point from the center of rotation. So if you can check, my angle looks like it's about approximately 90 degrees, right? It's 90 degrees approximately. So if I can check this point through the center, say the image is here. Okay, that's where the image is. Then, so this point done. Let me take another point. This point done. Then the next other point, next one, I can take this point. Then I will join with the center. Right. Then 90 degrees approximately. 90 degrees approximately is supposed to be. Let me just check like this. 90 degrees approximately. So this one, it will be like, is it approximately 90? Let me check the number of boxes. 1, 2, 4 boxes. So 1, 2, 3, 4 boxes. So it means it's supposed to be at this point. But this point is in line with this. It's a straight line, right? So it's supposed to be along the same line with this point. So it approximately there. Yeah. It looks like it's correct. So that's it. Then next, so that point done, these 2 points done, we're left with 1 point now, is this point. We join with the center. So using a ruler, join with the center. Then 90 degrees. Usually use a protractor to measure 90 degrees, right? Here, you measure 90 degrees on this line, So place a protractor like this. A protractor like this, then 90 degrees will be somewhere here. So along this line, something like this. So you measure. So the distance, now you measure distance of this point from the center must be called distance of the image from the center. Then you how many boxes? 1, 2, 3, 4. 1, 2, 3, 4. So it's supposed to be somewhere. The triangle must be of the same size. It must be exactly of the same size. Right. So a center, you just leave it marked. Then if I can join my triangle, it's like this. That's the image, yeah. Very correct. Very correct. Then next, part C, describe fully the single transformation that maps triangle T onto triangle A. T onto A. A is the image of T. Check size, the same. Direction, the same. R is a translation. If size the same, direction the same, it's a translation. Then we need the vector of translation now. Vector, you can say image side minus original side. A is the image. I can pick this point and this point. Right. So this point, what are the coordinates of this point? X4, y minus 5. Then minus its image point minus original point. Then this one it's minus 1, 1. X minus 1, y 1. Then you get 5 minus 6. Done. Just like that. Write this question paper done. Next question paper. Write this one. Draw the image of triangle A after a reflection in the line y equals minus 1. So first you draw the line y equals minus x. You draw your table of values to draw this line. So you put your x, your y. You choose x0, x1. Just end 2 points. It's a straight line. The power of x is 1. It's a linear graph. So x0, y0, x1, y minus 1. You plot these points. x0, y0, x1, y minus 1. Then you find your ruler. You join these 2 points. With your ruler, join the 2 points. Long line. Let me try it. So that's the line. So you label this line y is equals minus x. So I want to reflect triangle A on this line. Let's reflect. Distance of image the same as distance original from the line of reflection. You count number of boxes to the line, then from the line to the image, same number of boxes. This one is a slanting line. You go opposite direction. Right, let's start counting. This point 1 2 3, then 1 2 3. So the image is here. This point you can count downwards. 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. That's it. Then this point, the last point, right? You count even downwards, or this direction or this direction. So I can choose going downwards. So it will be 1 1 2 3 4 5 6 7 8 9. Then 1 2 3 to the line. Let me start again. 1 2 3 4 5 6 7 8 9. 1 2 3 4 5 6 7 8 9. This one. So it will be like, if we can join, this is a triangle. Done. Then next, draw the image of triangle A after a translation by vector -2 9. You can just use the counting method. This one -2 x direction and -9 y direction. So -2 you'll be going to the left, -9 you'll be going downwards. That's y increase is going upwards, decrease is going downwards. X decrease is going to the left and increase is going to the right. So if it's -2x is going to the left, now -9y is going downwards. So from each and every point you translate each and every point. So you'll be counting from the point, then x direction and y direction to the image. X -2, I can start with this point. -2 is 1 2. Then I count -9 going downwards. -1 2 3 4 5 6 7 8 9. So it's here. Then next point is this one. 2x 1 2 -2, then 9 going downwards. 1 2 3 4 5 6 7 8 9. It's here. Then the last point, this one, 2 1 2, then 9 going downwards. 1 2 3 4 5 6 7 8 9. It's here. Let me remove the unnecessary things here. Right, then you join your triangle. It will be this one, the red one. Yes, so that will be a triangle after a translation vector -2 -9. Next, describe fully the single transformation that makes triangle A onto triangle B. A onto B. Check on size is different, so that's an enlargement. So enlargement, you write enlargement. This one require enlargement center and scale factor. Scale factor of enlargement. So enlargement center and scale factor. Center, now you find it by you join the corresponding points, like this point and this point. You join them. Right, you join the other points. I can choose this one and this one. Right, so approximately, if you can check, they are meeting at this point, which is -7 8. That will be the center. X -7 y 8. That will be the center of enlargement. Done. Then scale factor. If the shapes are already drawn for you, you can say you can use scale factor is image side over original side. Length of image side is A onto B. So B is the image now, right? So you say I can choose which side, this side and this side. This side and this side. So I can choose B. How many boxes? 1 2 3. So it will be 3 boxes over A. 1 2 3 4 5 6 over 6. Then this will give you half. So scale factor half. Just like that. Just like that. The next excuse. The next part is triangle A onto triangle C. A onto C. A onto C. Right? Check on size. Size still the same. Direction different. So this will be a rotation. So it's rotation. On rotation, you want the direction, the angle direction and center of rotation. And the direction here is A onto C. So A onto C, check. We can check this point. This was on the north side. This point is now on the east. So it has been turned like this. From north to east, it's 90 degrees clockwise. So it's rotation, 90 degrees in a clockwise direction, 90 degrees clockwise. Then done. Then the center of rotation, right? You check which direction now. For the center of rotation, you can use your ruler. To find the center of rotation. But the angle must be exactly 90 degrees and the distance of the image must be exactly as the distance of the original point from the center of rotation. And this one is clockwise. So it's from A to C. So the line, it's supposed to be, it can be like this or it can be like this. So which one is which one now? If it's like this one, it will be anti-clockwise. This one is clockwise. Oh, so the first one is the one that will work. This first one. Right. So if it's like this now, so let's check now approximately. Let me put a line that is approximately 90 degrees. 90 degrees and the distance must be the same. It looks like it's 0, 0. It's 0, 0. Because distance here, 2 boxes, 1, 2 boxes. This one, 2, 1, 2 boxes. So it's center 0, 0. Just like that. Because this angle is approximately 90 degrees. This is the angle that we'll be looking at. That I'm talking about. This angle is 90 degrees. Approximately 90 degrees. So it's center. You write center 0, 0. Then done. Just like that. 3 marks. Right. Next paper is this one. They said on the grid, draw the image of triangle T. After a translation by vector minus 2 minus 1. Triangle T is this one. Then it means this one is X, this one is Y. I can just use the counting method. You can just add all the points of triangle T to vector 2 minus 1. Then you find the image points. Still to work. But counting is easier. So you count 2 X direction and minus 1 Y direction. Now the problem with this one now is like each small box represents half unit. So you take note of that one. Because 2 boxes it's 1, which means small box is 0.5 is half. So to count 1, you say you use 2 boxes. So counting method, that one now is tricky because you have to take note of the scale. Right, so in the X plus 2 is going to the right. I start with this point 1, 2. Then Y minus 1 going downwards. Y is the same also. So the point is here. Then this point is 1, 2. Then 1, it's here. Then this point is 1, 2. Then minus 1, it's here. That's minus 1Y. It's 2 boxes, 2 boxes. So counting method, you have to take note of the boxes. So it will be like this. Done. That will be the image of triangle T. After a translation, vector 2 minus 1. Done. Next question. Triangle T after a rotation 90 degrees clockwise about the origin. Origin is the center is 0, 0. You mark the origin 0, 0. Always mark the center of rotation first. So whenever you can hear the word origin, it means 0, 0. That's origin. So it's rotation 90 degrees clockwise of which one? Of T. So you join this point like this. So clockwise is which direction? Is this direction. That's clockwise. So it means you put your protractor like this. If you're using a protractor, you put it like this. Then 90 degrees, it will be somewhere here, somewhere here. Then you mark your point. You find your ruler, you join this point with the ruler. You join it. Then you measure the distance of the original point from the center of rotation. Like this distance. You measure this distance. Then approximately how many boxes? 1, 2, 3. It's 1, 2, 3, 4 boxes. Then the image will also be 4 boxes on this line. So it will be 1, 2, 3, 4. Somewhere. Yeah, somewhere. 4 boxes. Distance of the image is exactly the same as distance of the original point from the center of rotation. Right, you remove this part. Right, the image marked. Now, next point is this one. You join this point with the center like this. Then you put your protractor like this. Then 90 degrees approximately somewhere here. Yeah, that's 90 degrees. Then on this line, you measure the distance here from this point to this point. That will be the same distance with the image. So you say 1, 2, 3, 4, 5, 6, 7, 8 boxes. Then along this line, 1, 2, 3, 4, 5, 6, 7, 8 boxes. So somewhere. That will be the image of that point. Yeah, so you can just make use of a protractor. The protractor method is actually easier and better. Some they prefer to use tracing paper. Yes, still work. Then now let's join the last point, this one. So you put your protractor like this. You measure 90 degrees. It's approximately somewhere here. Yeah, that will be 90 degrees. Then you measure the distance from this point to this point. Let me count the boxes. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. I can say 9 boxes. Then here I can say 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. Somewhere here. Nine boxes. So it means the 90 degrees might not be that one. So this point and this point, they are joined by how many boxes? 1, 2, 3. There must be 4 boxes. So it means the 90 degree actually is not the real one. Right? Well, this distance must be 1, 2, 3, 4 boxes. 1, 2, 3, 4 boxes. So suppose it's somewhere. But this distance also 1, 2, 3, 4, 5, 6. It's supposed to be 6 boxes. That's this point and this point. Their images must be 6 boxes. So it means 1, 2, 3, 4, 5, 6. So this point was supposed to be here. And this point was supposed to be here. Something like this. Right, so that's what you find on your actual drawing. Like this. So it's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So the image. Even after finding one point, you can even find the other points. Right, this one done. Then next, triangle T after an enlargement. Scale factor minus half, center minus 2, 3. Scale factor minus, it means the image is on the opposite side of the center as the original shape. That's scale factor minus. Then half, it means the image is now half of the original shape. That's what half means. So first mark the center of enlargement minus 2, 3. X minus 2, y 3. There. Then the scale factor is minus half. Scale factor is minus half. Right, let me remove some other items here. Let me deal with this part on, right? Scale factor is minus half. So it says scale factor is equals to image, distance of image from sender over distance of original point from sender. That's what you use. Then scale factor, if you can cross multiply, scale factor times distance of original is called distance of image. So scale factor times, which is minus half here, times question mark, then to be distance of image. Then take point by point, you put where there's the question mark here. You just measure the distance, even with a ruler. You measure distance of the points, original point from the center with your ruler. Then in this case, more like you are dividing by 2. Multiply by half. You are multiplying by half. Distance of original times half. Then you get distance of the image from the center. But in this case, the image is on the opposite side of the center. Why? Because of the negative sign. But first thing, you join the sender with these points. You join this point first. So it means the image of this point is on this line. Then join another one. The other one is which one? This one. This one, I can choose this one. The image of this point is on this line. That's what it means. Then the last one is this one. The image of this point is on this black line, just like that. Right, let's now count, do our calculations. We start with the first one. Again, I can use boxes here, still to work. But the ruler method, you can just measure using a ruler. Then you divide by half. That will work very well. So I can count, I can start with this point. I can call this point A, B, C. I can start with point A. Boxes from the center, 1, 2, 3, 4, 5, 6, 7, 8. So it will be half times 8, which is equals to 4. So the image will be 4 boxes from the center on the opposite direction, on the same line. That's the blue line. So I count here, 1, 2, 3, 4. So it's here. Oh, nice one. All right, let me remove this one. And even the blue line, once I'm done with this blue line, and point A. Now moving on to point B. Let me count the number of boxes to point B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So half times 12. It will be 6. 6 boxes from on the same line. So it will be 1, 2, 3, 4, 5, 6. So it's here somewhere. Yes, somewhere. Then let me remove this one for B, and even the line, because I'm done with B. The point I have marked is this one, right? Then I'm left with C. C, how many boxes? 1, 2, 3, 4, 5, 6, 7, 8. From the center, please take note. So half of 8 is equal to 4. So 4 boxes on the opposite side, 1, 2, 3, 4. So it's here. That's where the point, the image of C is, like this. So this will be the triangle. It's looking ugly, but that's it. So let's choose. So that's the triangle, then done. That's the image after enlargement scale factor 2. So scale factor means the image is on the opposite side of the center, like this one, original, opposite side of the center. That's the way the image. That's the scale factor half, or negative scale factor. Then describe fully the single transformation that makes triangle T onto triangle A. T onto A. Check size. Size still the same. Check direction. Direction changed. But are the shapes facing each other? You can see, wow, they are facing each other. They are facing each other. Check this and this. They are facing each other. Because this side is this side. So this will be a reflection. Then reflection. First you write reflection. On reflection, you need the equation of the line of reflection. So you say reflection on the line, then find the equation of the line of reflection. Let's take the midpoint of these items. Right, to find the midpoints, you can use a ruler. You can measure the midpoint somewhere. According to my drawing, let me check. 10, so the fifth one. Somewhere here. Oh yeah, you can measure using a ruler. Somewhere 2.5. Somewhere here. So it's passing through somewhere this point and this point. Or what you can do, the easiest way, you can join this line like this. Then you can take the corresponding point, which is this point. Where they meet, it means the line is passing through that point. You write the coordinate of the point is -4, 4. Then you take another point like this one and this one. You can put this one and this one. Where they are meeting, it means the line is passing through that point. So it means my first point was wrong, but the second point looks like it's correct. I'll just have to remove it however. So the line is passing through these points. So if you can check these 2 points, -4, 4, and this point, it's actually -1, 1. It looks like y is equals to -x. Because y4, x is -4. y1, x equals -1. So y is equals -x. Just like that. That's the line. Right? But how can you find the line now? Equation properly. You can say use y is equals mx plus c. Y is equals mx plus c. Then c is the y-intercept. This graph passes the y-axis at y is equal to 0. So your c will be equal to 0. So it will be y is equals mx plus 0. Then find the gradient. Gradient, you can use that method. You can calculate. This one will be x1, y1. This one will be x2, y2. You can use gradient is equals to y2 minus y1 over x2 minus x1. This one, the inversal method, it works everywhere. So y2, it will be 1 minus y1, 4. x2 is -1 minus y1 minus 4. So it will be 3 over 3. Minus 3 over 3. Then it will be -1. So that will be gradient. So y will be m is -1, x plus 0. So the same as y is equals minus x. Just like that. So on the line y is equals minus x. Done. Next paper. This one they say draw the lines of symmetry of a rectangle. I just draw like this. These are the lines of symmetry. Just 2 lines of symmetry for the rectangle. It's not part of our transformation, however. Then next, right? They say describe fully the single transformation that maps triangle A onto triangle B. A onto B. A onto B. Size the same. Direction the same. This is a translation. So write translation. Then on translation, you want the vector of translation. Translation, then vector. You find the vector. I say image point minus original point. So it's A onto B. B is the image. I can take this point and this point. Right. So I can say B, this point is what? -6, 2. -6, 2. Then minus original point is this one, -5, -2. Like this. Then -6 minus -5 is -1. 2 minus -2 is 4. This is the vector. -1, 4. Done. 2 marks. Then triangle A onto triangle C. A onto C. Right, check. Size, the same. Direction, changed. But how is direction changed now? Are the shapes facing each other? Let's check. Are they facing each other? No. This side is not this side. So they are not facing each other. So if they are not, it's not a reflection. It's now a rotation. So this will be rotation. On rotation, you have to state the center of rotation, angle, direction of rotation. Right. So A onto C. I can check which point can I pick. I can pick this point. It's on the west. Then the same point is now on the south of the shape. So north and west and south is 90 degrees anti-clockwise. It has been changed anti-clockwise. So it's rotation 90 degrees anti-clockwise. Rotation 90 degrees anti-clockwise, done. Then next item, you check on the center of rotation, right? So center of rotation, you can use your protractor or ruler. Two rulers, they will make sense. Or a protractor, it will make sense. Check this point. Let me check this one and this one, right, for the center of rotation. So if distance of the image from the center is equal to distance of the original point from the center, if it's anti-clockwise now, it means it has been changed something like this direction, so that anti-clockwise will be like this. It can be this or this. This direction can also make sense, but from like this one, it will be clockwise now. But it's always from the original to the image. So it means the line that makes sense is the line that is. Now you have to put your ruler so that this ruler, the angle in between must be exactly 90 degrees. This angle must be exactly 90 degrees here. Right. Let's check now. Let's put a proper one so that you can check, is it 90 degrees exactly. For it to be 90 degrees, approximate, then distance of the image from the line, from the center, like this distance must be exactly equal to this distance, must be exactly be the same. So you have to use your ruler to measure that one, and this angle must be exactly 90 degrees. This angle must be exactly 90 degrees. If not, then that will not be the center of rotation. Okay, let's check. So you check the point that is a bit much more closer to that one. Let's check if I can use my ruler. This angle is not 90. Let me use my ruler 5 here. Yeah, so for this one to work, if it can be somewhere here, let me work with this point. So if I can draw, right, this one looks like it's working. Let me measure the distance now. 4.2. 4.2, yeah. So that will be the center. But this, you can check, this one is 90 degrees. So this will be the center. So center to 1. Center to 1. Just like that. Then you are done. Then draw the image of triangle A after a reflection in the line y is equals to 2. First you draw the line y is equals to 2. Y is equals to 2. You go with this y, 2. Then you draw your line. Right, that's y is equals to 2. So in the reflection of which triangle? A. Y is equals to 2. So A, it's here. Y is equals, so you count the boxes 1, 2, 3. You count 3, 1, 2, 3. So the image is here. This one, it will be this point 1, 2, 3, 4, 1, 2, 3, 4. So you count from the original point, this original point, to the line. Then same number of boxes from the line to the image. So this one will be 1, 2, 3, 4, 1, 2, 3, 4. Like this. This will be the image. Aha. Nice one. And you have to label your line actually. Label your line y is equals to 2. Please don't rub it off. Just leave it like that. It's part of your working. Next, draw the image of triangle A after enlargement scale factor minus 2, center minus 1, 1. Scale factor minus, it means image is on the opposite side of the center of enlargement as the original shape. Then 2, it means the image is now twice as big as the original shape. That's what it means. So you mark the sender -1, 1, -1, 1. This is the sender. And this which shape is triangle A. Right, so what you have to do now is I'm removing all these fun items so that to avoid confusion. But this one, you have to leave it, right? A line of reflection. Right. So I've marked my point -1, 1. Then what you have to do, you join your triangle with the sender. It means the image of this point is on this red line that I have drawn. Let me use different ink, blue. The image of this point, I use blue. You join with the sender. All the points. The image of this point, I can call this one A, this one point B, this one point C. The image of point B is on the blue line. That's what it means. Then now let me use my black ink. The image of C will be on the black line. So you join C. So the image of C will be on the black line. So you join all the points with the sender. And the image is now twice as big as the original. Scale factor is -2. So the scale factor is called distance of image from sender over distance of original point from the center of rotation or of enlargement. So this is the same as scale factor times distance of original from the center of enlargement. It's called distance of image from the center of enlargement. Right, scale factor is -2. You can just use 2 times question mark. It's called distance of image. This question mark, want to take all the points. So take first point, number 1. Take point A. Let's count the number of boxes. 1, 2, 3. All right, this one is difficult to count now. Let me start with C. C is 1, 2 boxes, right? C is easy, so it's -2 times 2, or just 2 times 2, it will be 4 boxes from the center along the same line. That's the same black line. So it will be, I count 4 now. 1, 2, 3, 4. So it's here. The image of C is here. Right, I'm removing the black line. Yeah, so we start with the points that are easier to do, right? Like in this case, C was easy. A looks like it's a challenge. Then let's find B. Some points you can find them automatically. Then B. B is how many boxes? 1, 2, 3. This one is easier to the center. So it will be 2 times 3. So it will be 6. Image of B will be 6 boxes on the opposite side on the same blue line. 1, 2, 3, 4, 5, 6. So it's this one. So my line, your lines might not be that accurate. So in line, you mark the closer one, right? The nearest box or corner. That's the one that you have to mark, right? Then we are now left with this A. A, let's count. 1, 2, 3, 4. It's 4. It's 4. So 2 times 4, it will be 8. So 8 from the center. 1, 2, 3, 4, 5, 6, 7, 8. So it's here. Yeah. Now let me remove all these fun items. Then you can be able to join these points. That will be your shape. After enlargement, scale factor -2. Right. So that's it. Semangea signing out. Thank you.